Gentlemen, this is Miss Humbert here. Sorry I couldn't be here today, but we're going to go ahead and talk through that review for you. So the first thing we're going to talk about are our comic books. Okay, so Dante spent $16.15 on 2 new and 5 old comic books. So let's let X represent our new comic books and Y represent our old comic books. Samantha spent $21.95 on 7 old, which is Y, and 2 new, which is X. So now we need to write a system of equations that says how much each type of book costs, and then we're going to solve it. So for every X new comic book, it's going to be an X price, and we're going to buy 2 of them. And then at the Y price, we're going to buy 5 of them. And that's going to be equal to $16.50. Then at the X price of the new, we're going to buy 2. This is for Samantha now. And for the Y price of the old, we're going to buy 7. And that's equal to $21.50. So now what we want to do is we want to solve this. So what I notice is that these 2 equations are in standard form, which means the easiest method to use is elimination. So what I'm going to do is I'm going to notice that the X both have the same coefficient. So that means I can go ahead and I can create the opposite sign. So let's go ahead and rewrite out that new system. So I'm going to keep 2x plus 5y is equal to 1650 on top. Then I'm going to take the negative 1 and I'm going to distribute it to each of the things in the following equation. So I have negative 2x minus 5y is equal to a negative 2150. So now I can go ahead and I can add down the columns. 2x minus 2x is going to cancel out. Oops, this should be 7y. Negative 5y minus 7y is negative 2y, and 1650 minus 2150 is going to give me a negative 5. So now to solve for y, I need to divide both sides by a negative 2. Well, when you divide a negative and a negative, it becomes a positive. 5 divided by 2 is going to give us 2.5. So it's $2.50 for old comic books. Because remember that y represented old comic books. So you can go ahead and write that down. Next, let's go scroll back up and let's take a look at our original equation. So we can plug that back in for y so we can figure out what our x is. So I'm going to rewrite out that top equation. I'm going to take the x out completely and I'm going to put the y in instead. And that's going to be equal to 1650. So now I have 2x and then 5 times 2.5 is going to give us 12.5 and that's equal to 1650. Then I'm going to subtract 12.5 from both sides. Okay, so then these guys cancels, and over here I'm left with 2x is equal to 1650 minus 1250, which is going to give us, 4. Then we're going to divide both sides by 2, and we get that x is equal to $2. So it's $2, and we want to make sure we note for old comics. So $2 for new comics. $2 for new comics. Let's go ahead and let's take a look at number 2. Twice a number minus a second number. So let's let x represent the first number, y represent the second number. So twice a number minus a second number is 9. Twice the second number added to 3 times the first number is going to be 31. So now we want to go ahead and we want to solve this system. So the first thing I'm going to do is line up my columns. So I have 2x minus y is equal to 9. And then I have 3x plus 2y, so I have my y's in the same columns now, is equal to 31. So here's what I notice about my y's. I notice that here I have opposite signs, but I don't have the same coefficient. So I'm asking myself, okay, what do I need to multiply 1 by to get a positive, or to get a negative 2. And so I'm going to have to multiply that first equation by 2. So I'm going to go ahead and do that. So 2 times 2 is 4, times a negative 2y is equal to 18. And then I get 3x plus 2y is equal to 31. So now we can go ahead and add down the columns. 3x plus 4x is 7x. My 2 y's are going to cancel. And then I'm going to get 18 plus 31. So I'm using elimination on this one. If you want to use substitution, you can do that as well. And that's going to give me 49. Divide both sides by 7, and I get that x is equal to 7. So that's our first number. Our first number is 7. So now we want to figure out what y is going to be. So I'm going to go ahead and I'm going to plug x into this equation right here. So I'm going to take x out completely and I'm going to put 7 in instead, and I'm going to leave the rest of the equation the same. Well, 2 times 7 is 14 minus y is equal to 9. So I'm going to subtract 14 from both sides. And then I get that a negative y is equal to 9 minus 14, which is going to give me a negative 5. Then I want to divide both sides by a negative 1 because that's what's going to get rid of my negative. I don't want to know what a negative y is. I want to know what y is. Negative divided by a negative is a positive, so I get that y is equal to 5. So those are the two numbers that we are going to use. Okay, so let's take a look at some solving systems. So when you're solving systems, the biggest thing you want to decide is which method would be easier, because we like easy things in life, right? So what I noticed about number 3 is that it is already solved for x. X is equal to 7 minus, or y minus 7. So x and y minus 7 are the same thing. So where I see x down here, I can plug in y minus 7. So then I get y minus 7. That substitutes out the x. Now the rest of the equation is going to stay the exact same. All I did was take the x out and put y minus 7 in instead. So y plus 3y is going to be a 4y minus 7 is equal to 29. So then I need to add 7 to both sides. And then I get that 4y, 29 plus 7 is 36. So 4y is equal to 36. Divide both sides by 4, and you're going to get that y is equal to 9. So now I know y is 9, so I want to figure out what x is equal to. Well, conveniently, this top equation up here is solved for x. So what I'm going to do is I'm going to write everything out the same, but now I know that y is 9. So I'm going to put 9 in instead of y. X is equal to 9 minus 7, which is 2. So now we're going to write that out as a coordinate point. First our x, and then our y. So that's our solution for number 3. Let's go ahead and take a look at number 4. So for number 4, I see that here for my x's, first of all, that it's in standard form, and I have same coefficient opposite signs on my x's. Same coefficient opposite signs. That makes it really easy to use elimination. So that's what I'm going to do. I'm going to add down the columns. X minus x is going to give me 0x. 2y minus y is going to give me y. And then 2 plus 1 is going to give me 3. Now remember, when you're using elimination, you always add down the columns unless there's a negative. So this 0x cancels out, and I'm left with y is equal to 3. So now I know that y is equal to 3. So where I see y up here, I can plug in 3. And it doesn't matter which equation I choose. I'm going to go ahead and use the first one. So I'm going to write everything out the same, except I'm going to take the y out, and I'm going to put 3 in instead. And that's equal to 2. So then I get x plus 6 is equal to 2. Now to solve for x, I need to take that positive 6 and bring it over to the other side. Well, I do that by subtracting 6. So I get x is equal to a negative 4. So then we can go ahead and we can write out our points as a coordinate point. So I get negative 4 for x and 3 for y. Okay, let's take a look at number 5. So for number 5, I see that system, I see that this is a positive 1x. So to me, it makes sense to use substitution. You could use elimination if you want. You'll still get the same answer. So what I'm going to do is I'm going to take this first equation and I'm going to solve it for x. So I'm going to subtract 2y from both sides, and then I get that x is equal to a negative 2y plus 13. So that's going to replace this equation up here. X is equal to a negative 2y plus 13. So then now I know that x is equal to this guy right here. So where I see x down here, I can plug in that exact equation. So I'll keep the 2 there, but instead of writing x, I'm going to write negative 2y plus 13 minus y is equal to negative 4. So then I'm going to distribute in my 2. So 2 times a negative 2 is a negative 4, and we're going to keep the y. 2 times 13 is 26, minus y is equal to a negative 4. So negative 4y minus y, now that's going to get more negative. So that's going to become a negative 5y plus 26 is equal to a negative 4. So now I need to subtract 26 from both sides. And I get a negative 5y is equal to negative 4 minus 26, again, getting more negative. So that's going to be a negative 30. Divide both sides by a negative 5. Negative times divided by negative is positive. 30 divided by 5 is 6. So now I know that y is 6. So where I see y, way up here, I can plug in 6. So I get x is equal to negative 2 times 6 plus 13. Okay, so then I get negative 12 plus 13. So then I get that x is equal to 1. So now I can write that out as a coordinate point. First my x, then my y. So that's 1, 6. Cool. Let's take a look at number 6. So for number 6, I want to go ahead and use elimination. The reason why is it's in standard form, and I see that my x's already have the same coefficient. Okay, so now what I want to do is I want to make them opposite. So I'm going to take the second equation and I'm going to multiply it by a negative 1. So that negative 1 needs to distribute in everything in that second equation. So I have 2x plus y is equal to 9. Negative 2x plus 3y is equal to 3. So now I can go ahead and add down the columns because here I have the same coefficient with opposite signs. So those guys are going to cancel. Y plus 3y is going to give me 4y, and then 9 plus 3 is going to give me 12. Divide both sides by 4, and here we get that y is equal to 3. Now that we know that y is equal to 3, we're going to take 3, plug it back in up here for y, and solve for x. So we get 2x plus 3 is equal to 9. Subtract 3 from both sides, 2x is equal to 6, divide both sides by 2, and we get that x is equal to 3. So we're going to write that out as a coordinate point, x, y. All right, let's take a look at that last problem. So to get it in slope-intercept form, remember that slope-intercept form is y is equal to mx plus b. So to do that, we first have to put this in point-slope form. So that's the one that we set up like a puzzle. Okay, so in here we're going to put our slope. So our slope is 3. And here we're going to put the opposite of our x-coordinate. Since it's a positive 2, we're going to subtract 2. And here, opposite of our y-coordinate, so it's going to be minus 5. And now I need to solve for y. So I'm going to start by distributing in that 3. So I get y minus 5 is equal to 3x minus 6 when we multiply that 3 to each thing. Last thing we need to do to solve for y is to add 5 from both sides. So y is equal to 3x minus 1. Let's take a look at number 8. So for number 8, we need to get the y all by itself. So first we need to get rid of that 3x. So what I notice is that's a positive 3x. So to get it over to the other side, I need to subtract 3x. So then I get 4y is equal to a negative 3x plus 32. Then to get that y by itself, I need to divide both sides by 4. So then we have our y is equal to, now when I'm dividing by 4, I'm going to notice that each part needs to be divided by 4. So then I get a negative 3 divided by 4x, and then 32 divided by 4, which is going to give me 8. So that right there is your slope-intercept form, and that concludes your review. So go ahead, give this review to the substitute, and then you can go ahead and get your quiz and get started. Do the best you can. I know you're going to do great. Thanks for listening.